Welcome to this innovation talk around safety view and how we can help you operate your plant at the highest level of safety. Today, I'm pleased to welcome Steve Elliott, who has over 30 years of experience in helping customers improve the safety performance.
Thank you. It's a pleasure to be here.
We are here today to talk about how bypass management and critical alarms are important to safe operations. But this isn't new. How are these functions typically managed today?
For as long as we've been designing, operating and maintaining plants, there's always been this need for bypassing for many reasons. It could be during startup, during process transitions, for maintenance, testing, replacing failed equipment, etc. But you may sometimes hear bypasses referred to by other names, such as inhibits, suppression, forcing, impairments. But at the end of the day, whatever you call it, a bypass by any name is dangerous. Well, why? Well, it nearly always means that the safeguard will no longer be able to provide the full degree of risk reduction it was specified to perform. So the continued safe operation of that facility will usually then depend on the timely implementation of compensating measures to provide the risk reduction that was lost through the act of bypassing. There are several different ways of applying bypasses. These can be as simple as just hardwiring jumpers across terminals. Hardwired key switches may be used, but these require more I/O, wiring, engineering, space. They're difficult to expand or modify, and it's all too easy to make a mistake and bypass the wrong tag. Sometimes the safety system engineering tools may be used. Now, in this case, you'll certainly need specialist safety system knowledge, and you'll need to understand the application logic. Or the DCS may be used, but be careful because the DCS will be writing to the safety system and therefore impacting the safeguards. So check what the safety standards say. For example, IEC 61511, section 11.7.2 is quite clear on the mechanisms required for safe operation. Or a traditional HMI may be used. Now, these implementations are not safety certified, and they're often bespoke, which means they require additional scripting, additional engineering, which adds up to a higher implementation and total lifecycle cost. So there are a few different ways to implement a bypass. But it's also the same for critical or priority alarms. Again, there have always been these alarms, but how they are implemented can differ. For a long time, hardwired alarm annunciator panels were used. Now, these require more space, more power, more I/O, the wiring, the engineering, and they're difficult to expand or modify. And they certainly aren't very helpful when you're doing the shift handover or if you're having to do some form of post-trip analysis. Sometimes critical action panels are used. Again, these suffer from the same challenges as the hardwired alarm annunciator panels and key switches. Again, we see the distributed control system used for critical operator alarms. But if you consider your critical alarms as safety related, then this may not be the best way or the place, as the critical alarms can just quickly get lost in a myriad of screens, and therefore they may not always be visible to the operator. And sometimes we see all the combinations of these methods on the same plant, especially as it gets expanded or upgraded over the years. But like everything, there is a natural evolution. Nothing stays the same forever. Just think about your smartphone. Once upon a time, you needed a separate phone to make the calls. You needed a separate camera to take pictures. You needed a separate Walkman to listen to music on the go. You'd have a separate computer to search the web. Now, all of that is available in one device, but it's not just what you use. It's also changed how you use it.
What's the new improved way?
One new way, an improved way, is to use Safety View. Now, Safety View is a TÜV certified bypass and alarm application that is designed specifically to help operators manage those high-risk bypass and critical alarm conditions. Let's look.
In high-hazard industries, operators are critical to safe operations. Anything that can be done to help operators maintain the highest levels of safety, especially during elevated risk conditions, is a good thing. During everyday operations, there are instances where equipment needs to be bypassed for maintenance or testing. This can be risky, as it may require experts to change settings in the safety system. Every bypass directly impacts the safeguards required to keep the plant safe, increasing the cumulative risk and potential likelihood of an incident recurring. Under such conditions, operators need to pay close attention to critical process conditions, as well as critical alarms to keep people, production and profits safe. Introducing Safety View, the only TÜV certified bypass and alarm management system designed to help operators safely manage plant operation. With Safety View, information is clear and not buried in a myriad of screens or lists. Operators can consistently and systematically apply bypasses. See what is in bypass and why. Know who applied the bypass and when. See critical alarms and process-related conditions, as well as manage alarm situations. General purpose buttons allow for faster operator response. All of this provides context for better and more timely decision making, enhancing operator performance and avoiding potential incident. Safety View alarm and bypass management, helping you improve safety performance, reduce operational risk, and operate in a certified, safe and cyber-secure way.
Let me show you a real example. So here you can see an operator console with two sections, one for operator A on the left, one for operator B on the right. Each has dedicated screens for control of the process. And if you look at the end of each console, there you can see Safety View. Each operator always has a clear view of those critical alarms and bypass conditions, so he always knows what to pay attention to.
Can you show me how this can help people do their jobs more effectively?
Let's put ourselves in the place of the operator and go through some of the daily activities, starting with a shift handover. Alarms and bypasses can be reactivated on the shift handover for the new operator to accept. Each alarm or bypass can either be accepted individually, or the operator can choose to accept all. Safety View alarms can be configured per the ISA S18.1 alarm standard for auto reset, manual reset, and ringback. For example, when configured as an auto reset, the alarms will automatically reset if number 1, the operator has acknowledged the alarm, and 2, the process conditions return to normal. For a manual reset, then it's the operator that needs to manually reset the alarm. So the alarm will only reset if it has been acknowledged and the process has returned to a normal condition, and the operator then resets the alarm. A ringback alarm occurs when, first of all, an alarm has been acknowledged and a previously abnormal process condition returns to normal. A new audible or visual alarm alert lets the operator know that the condition is no longer out of range. So then the operator can acknowledge the ringback alarm before it can be reset. Group alarms allow multiple bypass and alarm objects to be viewed together, so as a single alarm in the object view zone. A maximum of 30 bypass and alarm objects or child alarms can be grouped together into one single alarm. A first out alarm is the first alarm generated from a controller. So identifying the first out alarm can help you determine the first event in a series of events that may have caused the plant trip or any other abnormal process conditions. First out alarms can be identified by the appearance of a first out icon in the small box of an alarm faceplate. And more than one first out alarm can be configured for different lines of equipment. Disabling an alarm places that alarm out of service, so the alarm will not be triggered even if the related process value exceeds the defined limit. So it allows you to stop monitoring the alarm without having to delete it from the configuration. So when you want to resume monitoring the alarm, you just re-enable the alarm. General purpose buttons allow operators to perform specific commands on an alarm or a field device or even on the plant conditions. So for example, if a process goes into abnormal state, such as a tank level exceeds the defined limit or a motor overheats, the operator can use the GP button to shut down that device instead of manually shutting it down using a hardwired switch. Safety View supports a common bypass master permissive, be that hardwired or software. Only when the master bypass is enabled can the operator then apply or disable bypasses. Safety View can be configured to prohibit the bypass from being removed if the process is in a potential trip condition, so it stops the operator from inadvertently tripping the plant or the process. These are just a few examples of Safety View functionality. If you would like to see more of the functionality available, I strongly recommend requesting a free demo with one of our safety experts.
So what makes Safety View different?
Two things. First, Safety View is segregated from the DCS. The integrity of software that's used in safety-related applications is extremely important. You need to know that it will work when needed and that it won't introduce any adverse effects. And if you refer to safety standards such as the IEC 61511, 61511, then go check out section 11.7.2 because it's very clear on the mechanisms required for safe operation. Safety View is TÜV certified for specific use in safety-related applications up to Safety Integrity Level 3, SIL 3. And it's certified to Systematic Capability SC3 according to 61508. So Safety View is certified and closely coupled to the high integrity safety systems. And secondly, Safety View is cybersecurity certified to IEC 62443-4-1 to Security Level 1, SL1, specifically for software applications according to that cyber standard IEC 62443-4-2. You know, as I was preparing for this webinar, I was reminded of the Charles Darwin quote about survival of the fittest. But I would contend that in today's environment, it's now about the smartest. We aren't reinventing bypasses or critical alarms. What we're doing is finding a smarter way to make people's jobs easier, make them more efficient, make them more effective. Anything that can be done to help operators is a good thing. Putting a renewed focus on operators, it doesn't mean that we must do things the same old way. Those operators are critical to safe and profitable operation. So let's help them know what to pay attention to, especially during those high-risk conditions. And SafetyView does just that. It helps improve safety, it helps reduce operational risk, it helps companies to operate in a certified safe and cyber secure way. It is the only TÜV certified bypass and alarm management application to help you deliver profitable safety.
We hope that this webinar has provided you with an insight of how you can operate your plant at the highest level of safety. Thank you for staying with us, and thank you, Steve, for your valuable contributions.